Welcome to the fourth tutorial session of problem solving through programming in C. So this is a NPTEL course floated by Professor Anupam Basu from Department of Computer Science and Engineering, IIT Kharagpur, and I am Siddhant. I'm one of the four TAs who have been allotted to help you out with some sample questions which you might face in the assignments and in the final exam. So let us start this session. This is session number 4, which will be covering the contents of week 4 and solving some questions related to that. So in week 4, mostly if else statements, switch statements, and looping statements were covered. So we'll just have an overview of the concepts that were covered and solve some sample questions regarding that. Okay, so the first question here that I have for you is something that is carrying over from the previous week's lectures, that is regarding the if-else statements. So let us first try to solve this question. So here it is asking what is the output of the following C code. So there is a function here with a integer variable x which is set to 1, and then we have and the condition, that is x, if it is equal to 0, then it will execute something, and then inside that we have, if x is greater than equal to 0, then it will print something else, it will print something else, and it will return 0. So what should be the output of this C code? You can either unmute yourself, or you can and speak the answer, or you can just write it in the chat box so that I'll be able to see that. So these are your options. So what exactly will the output be here? Okay, yeah. So the option here, the answer will be option D. Why? Because you see, the first look at the first if statement. The first if statement is if x is equal to 0. That is, if x equals 0. Does that equal 0? No, that does not equal 0. So what is the block of statements which is within this first if condition? So you can see the next statement that follows the first if statement is the second if else block. So this entire block is actually, this is one block of statement, right? Or you can say it is one compound statement, because it is a single if else condition. It is a if else condition, so it is a single compound statement or a single block of statements. So this entire block of statements comes under this if condition, even though we have not given any curly braces here. So if we have not given any curly braces, that basically means that the next statement, whatever is following this if statement, is that is what is included in this if statement. So here the next statement, or rather the block of statement that follows the first if statement, is this entire block that I have marked within a rectangle, right? So this entire block of statements will not execute if x is not equal to 0. So in this case x is equal to 1, so this condition is false, right? So this condition is false, and this entire block of statements, it doesn't execute, and it directly goes to the next statement, which is return 0. So return 0, simply it will come back to the user, and there will be no output as such, because this entire block is completely ignored, because this condition became false. Is that clear to everyone? Why exactly not having curly braces here was problematic in a way? If you wanted this to be printing out, so you needed uh, this condition. There should have been some kind of curly braces here if you want to demarcate. So it is a good practice to put curly braces whenever you can, even if there is a single statement that you want to write after if statement or else statement. It's a good practice, especially for beginners, to use a set of curly braces for starting and ending block of statements. Okay. Okay, so if anyone has any doubts here, you can directly unmute and tell me, or I'll be moving on to the next question then that I have on the screen here. Okay, so let's move on to the next question. So, what exactly will be the output when this following C program is executed? So, in this C program, we have compared these two characters, and we are printing if this condition is true, then we are printing something, and if it is false, then we are printing something else. So, what should be the output in this particular output of this particular code? Can someone just write the answer in the chat box? Okay, okay, fine. So I guess this is fairly easy on your part. Okay, so the answer here is option A. Why? Because here every character in C has a ASCII equivalent. So there is a ASCII equivalent for every character. So basically, when you say A, that is this letter capital A, this has a ASCII equivalent of 65, and similarly this small a, it has a ASCII equivalent of I think 98 or something, if I'm not wrong. So because this has a ASCII equivalent which is less, when you write um, capital A less than small a, that gets converted to basically 65 less than 98. Okay, because it considers ASCII equivalents of this particular characters. So every character has their own ASCII equivalent. So if capital A is 65, capital B will be 66, capital C will be 67, and so on. Similarly, small a, if it is 98, then small b will be 99, uh, small c will be 100, and so on. Just a minute. So, yeah, so Sri Chandana Pratap, which question do you want me to repeat? The first one? Okay, okay, fine. Yeah. Okay, so yeah, let me just finish this one and then I'll go back to the first one. Is that okay with you? Okay, so I'll just quickly finish this one. So here we had two different characters which are being compared. So instead of comparing the characters directly, because it's not possible to compare the characters directly with the knowledge that we currently have. So what the compiler does internally is that it converts them to their respective ASCII equivalents, which is for capital A it is 65, for small a it is 98, and then it does the comparison. So here the condition is definitely true because 65 is less than 98. So this particular statement will be executed. So NPTEL will be printed out by this particular code. So the answer is option A. Okay, so I'll just briefly explain the previous question. So here we had a condition. First, we had a if condition where your x equals 0. That was the condition we had, and x has had the value of 1. And so this particular condition, it turned out to be false, right? Because x is not equal to 0, so this condition is false. Now, if this condition is false, the entire block of statements which is under this particular if condition will not be executed. So if you write any if and some condition, so the entire block of statements that is within this block of statements, this will not be executed if it is false, right? So this is what has happened here. So this the next statement here, there is no curly braces. That means only the next statement that is following the this particular if statement, the first if statement, the next statement that is following the first if statement, that should that constitutes the if block. Okay, so uh, in this case, however, what happens is the next statement which is following this if statement in the absence of curly braces, that itself is a compound statement, that is a block of statements. Why? Because it is in itself it is a if else statement block. You see, it's a again it's a condition if x greater than equal to 0, and you have a block and you have else something else. So this entire thing, it's another one, it's another block of statement. It constitutes a single block of statements because this is a if else conditional statement. So this constitutes a single block of statements. So when you consider that the next statement following this first if condition, the next statement is actually this entire thing, because this is one block of statements. This is one compound statement, you can say. So if this is one compound statement, this is the next statement which occurs after this if x equals 0 condition. So if this turns out to be false, this entire statement will not be executed. So that is what is happening here, because this condition x equals 0 is false here because x is 1. So this entire compound statement that we have here, which is the if else other if else block, this if else block is completely getting ignored, and we are directly, the program is going to the return 0 step. So there is no output from this particular C code. Is that clear? Okay. Screen size, I'm not sure what exactly you want me to do. Okay, let me maximize it as well as I can. Is it any? Okay, you guys cannot see the full screen. Yeah, that will be a bit difficult if I have to remove. Okay, it's not showing the full size. Okay, okay, okay. I'm actually doing a full screen and then I am showing, but yeah, I'm actually doing it on a full screen, but whether it's showing to you or not, I'm not clear about that. So for now, for example, now I am in full screen. Are you able to see the full screen, or are you not able to see that? Yeah, text will, yeah, it's okay if the text is visible. Due to the text, the programming is not visible. Okay, fine. Then I'll write less on the on the screen itself. Okay, fine. Um, okay, I have more blank space here, so I'll probably use that space instead of writing it near the code. Okay, fine. Thank you for the suggestion. So the next question that we have here is what will be the output of the following program. So we have this particular code where a variable, there is a variable a, there is a variable b, both are integer variables with values 0 and 10 respectively, and then we write if a equals 0, and we print something for the if part and the else part. So what do you think should be the answer for this particular code? Like what should be the output of this particular code? Okay. Okay, so answer here will be option B. Uh, yeah, because in this particular step, you can see that we have this if a equals 0. So instead of writing a double equals 0, which would be the relational operator that we have written simply a equals 0. So that means a value of 0 is being considered here in the if condition itself. So when you consider this entire thing inside the if, so when you write if a equals 0, now if I had written a double equals 0, this is a condition and a's value was 0, so this should have been true. Okay, but if because I have written if a equals 0, the this basically translates to if of 0. That means it saves the value of 0 in a, and the entire value of this if condition, it becomes 0. That means it's a false. 0 means it's a false, right? Any other value apart from 0, whether positive or negative, it would have been true. But because it's 0, it is false. Now if it as it is false, it will go to the else part. It will not print this part, it will print the else part, hence it will print false. So quite a few number of you got this right, so I don't think. Yeah, because the compiler see it as 0, that means it is false. Yes. So if there had been some other value, say you had written a equal to 5, say instead of 0, it would have been true, and instead of, you would have got true printed instead of false. So even if you had written a equal to -5, then also it would have been true, and you would have seen true being printed there instead of false. Okay. Okay, so uh, let's go to the next question. So here we have another question for, it's not exactly if else, but it's something related to conditionals. And so we have three different variables x, y, and z, integer variables, and we are saving x as y equals z. So when we print x as an integer, what will be the output of this particular code? Um, yeah, Srividya, if instead of 0 it was 1, so if I had written if a equal to 1, true would have been printed. Okay. Okay, so what is happening here? So basically we are evaluating x is equal to z. So 5 equal to 5, which is true, and true basically we are saving x equal to true, and x is a int. That means it will store x is equal to 1. Okay, because it is true, it will automatically, as an integer, it will store 1 instead of 2, because true is a boolean value. It's true and false are say this is the boolean value. So it will convert it to an int value, which is basically true, which is basically 1. So here 1 will be printed. So B is the correct option here. Okay. So I hope this has been clear to you. So next we'll look at the switch statement. More or less it has been covered in class, so I'll just go through it pretty quickly. So in switch statements we have this expression like similar to is basically the conditional, okay, which is basically similar as the if condition that we have. Then we have different cases. This is the value 1. This is the first value which is possible. This is the second value which is possible, and then this is like the default value. Okay, and accordingly there is a block of code which will be executed if this condition is true. Okay, so when I say this is a conditional, that is it you are basically playing with the value. This entire thing, if I am to write, I'll say that it translates to if say s is equal to x. Okay, something like that. This particular expression translates to this. So you will put switch of s, and your case 1 or case will be x. Okay, then if this is true, then the first block will execute, and then it will break before going to the next block. So I'll tell this question is regarding this break part, so I'll let you answer this, then we can discuss. So what will be the output of this following code? We have an integer variable x, which has the value of 1, and we write switch of x, and we write case 1 and default cases. We define the two different cases, and we have a return 0. So what will be the output of this particular program? Okay, yeah, that is correct. So we'll have both A and B being printed here, because so basically when we are saying that switch of x, then it will first start with case 1 here. So it will check if x is equal to 1. So x is equal to 1, that is true. So this particular statement is printed. But now because we don't have a break statement, it will go on and it will check with the default case. Default is something that should be executed when none other conditions are matching. That is, if the expression that we have given here does not match with x or y, the default should be executed. That is the purpose of the default part of switch case. But here, because we don't have a break statement, it will automatically go to the default case and it will print this one as well. So this is something called a fall through. Okay, so this is a term used for switch case statements. When you miss the break statements, it will go on printing until it encounters a break statement or it encounters the end of the switch case. So here if you had written a break, then it would have printed only choice is 1. Because there is no break statement here, it will print this, then it will go on and it will check with the default case and it will print the default case part as well. If there were other cases, case 2 and so on, there also it would have printed until it encounters a break statement or it encounters the end of the switch case. So in this case, both the statements will be printed, choice is 1 and choice other than 1. Okay, is that clear to everyone? Okay. Okay, so let's move to the next part. There is another two more switch case questions that I have for you. So this is basically a snippet of, of the code. This is not the entire code. We have a switch statements where this is an expression. So this is the expression that we have, and then we have this case, and we have written case less than 35, and we are printing something, and the default case is we are printing something else. So what exactly, why, like which statement is correct for the following lines? What should be the answer here? Yeah, so it will give us a compilation error. Why? Because of this less than symbol. So in case you're just allowed to compare it to a value, like you can write 35 here. So basically what that means, that if temperature in Celsius, this variable is equal to this value, that is 35, then it will print whatever is in this block of this case statement. But you cannot write that case for all cases less than 35, this is what it should print, right? If I want to say, if the logic here is that I want to print no matter what the value till 35 is, I want to print um hot day, okay, then I would have written something like case 1, case 2, just without giving anything in them. I would have written case 3 like this. I would have written till case 35, and then I would have written this printf whatever, and then I would have written break, so that whatever value comes within this 1 to 35, for any value it will print hot day, right? And if it is greater than this or beyond this, for any other values, it will not print this particular. And here the break statement is also missing. So if we would have not written this less than symbol also, in that case both these statements would have been printed, okay. But in this case it will give a compilation error because this is not allowed, like this less than symbol here, it's not allowed. Okay, I hope no one has any doubts till now. Okay, so let's go to the next question. So we have okay, one floating point variable which is num, and it is initialized to 5.6. Now we are writing a switch case statement of switch of num, that is this variable, which is constitutes the expression, and then we have case 5, case 6, and default, and then we are printing the num. So what should be the answer here? Okay, so yeah, the answer here will be compilation error or compiler error, because num, this is a floating point variable, right? So basically that what that means is it can store this decimal data, like digits after the decimal. So it is a floating point variable, and switch does not work with floating point variable. Okay, in C, switch does not work with floating point variable. That is, you can use only integers or characters and so on. You cannot use any floating point variable. So because you are using a floating point variable here, which is the value of 5.6, um, here you will encounter a compiler error. Okay, I hope that was quite straightforward. No doubts till now. Okay, so we'll go to the next one. So here, just a brief overview of the looping statements. As you know, the lectures already discussed this. We can have Um, so it's basically counter controlled statements and sentinel controlled statements, right? So these are two different ways you can write the looping statements. And there are three different looping statements as far as we are concerned in C. That is for loop, while loop, and do while loop. And there are different, they each of them have their own syntax to follow. So for example, this is the for statement. Here we have a variable I. This I variable is called the iterator because it iterates from 0 till 10 in counts of 2. So when we write I plus equal to 2, that basically means I is equal to I plus 2. So, and that is increment is done at the end of the iteration. That is, first we are initializing it. So here we are writing I is equal to 0. Then we are checking with the condition, that is I is less than equal to 10. If the condition is true, this it will print this, and then it will increment i's value with 2, and then it will return back and check with the condition again. So this will continue until this condition becomes false. So here for the first one it will print 0, then it will print 2, then 4, then 6, then 8, then 10, and after when it printed 10, that is the value of I is 10, and it will increment it and become 12. It will go back and check with this condition. So this condition will become false, and it will exit from the for loop, and it will go to the return statement. So the answer from this code, from this particular code, will be from 0 to 10 in steps of 2. Okay, so the while loop, on the other hand, this is also pretty much similar, just that the initialization condition is separately given instead of in the for loop. You saw that the syntax itself had the initialization, but here we give a separate initialization, and the condition is still checked first, and if it is true, then the increment also is done separately. Like it's not mandatory to write in for loop. Also it's not mandatory, but usually there is a space for writing the increment part here, right? Like we have the space for the initialization, the condition, and the increment or decrement part. In while loop we have only the condition to write here, and the increment and the initialization are done separately. Okay, that is the entire difference between for and while. So while can actually be used is rather, I would say it is more usually used for the sentinel controlled looping rather than the counter controlled looping, because we usually use while when we don't know how many iterations this particular code will run for. Okay, um, but you can use it for either counter controlled or sentinel controlled. Okay, so then there is this third looping statement, which is a do while loop. Here the first difference is that the first and the very important difference is that the condition checking occurs at the end. So there is definitely one iteration always occurs. Okay, because the condition is checked at the end of the loop, one iteration will definitely occur all the time. So when you start it with the do statement and you print this and you increase the iteration and whatever, and then finally the condition is checked, by that time even if the condition is false here, the statements have been executed once. So definitely one iteration always occurs in case of do while. That is the biggest difference between for loop, while loop, and do while loop. Okay, so just a brief overview of the looping statements. Next we'll go into the questions. So we have two questions here. Uh, the first is we have a complete code here. We have variable n, x, and y. These are three integer variables. We are asking the user for a input, for a integer input, and the user has inputted some n, and then we are doing some kind of a calculation here or a computation here, and we are printing something. So um, the best way to tackle such kind of questions is that take any input, say uh, my input would be 123. Say I'm taking an input of 123 and run the entire duration, like check, start from here. This is the input statement, right? So here I would have inputted n is equal to 123. So run the entire while loop until this condition becomes false. That is a way of um, tackling this kind of questions. Um, if you are not able to know what exactly it will be intuitively, then this is a way that you can just calculate it, take any sample number, and run it through the entire while loop or whatever, and then see what is the output. So just do something like this and try to solve this question and answer it, which of the options should be correct here. So what exactly would happen here? Let me do it for this N123. So first it will check. Okay, let me. Okay, fine. So n is not equal to 0. So 123 is not equal to 0. This is true. So this will still be executed. Y is equal to 123 percentage 10, which will basically give you 3. The last remainder, when 123 is divided by 10, the remainder will be 3, and that will be stored in y. Then x is equal to, x is currently 0, and we are doing minus y, that is minus 3. So the value of x is minus 3, and n is an integer, keep that in mind. So we'll do 123 by 10, which is basically 12. The part after the decimal will be dropped because this is an integer variable, so we cannot store floating point here. Okay, so this is the first iteration. This entire thing, this is the first iteration. Then after this, what happens? So we'll check 12 not equal to 0, still true. So our y will be 12 percentage 10, that is 2, and x, what is x? X is minus 3, right? So x is minus 3 and minus y, that is minus 2, it becomes minus 5. N is n by 10, that is 12 by 10, that is 1. So it is basically 1.2, but the integer part is only retained, so it is 1. So this is our second iteration, right? Then after that, what happens is 1 not equal to 0, it is still true, it is not equal to 0. So y is equal to 1 percentage 10, that is 1. X is equal to minus 5 minus 1, that is minus 6. And n is equal to 1 by 10, that is 0.1, that is 0. So this is our third iteration. Now when it goes back to the condition, it will check 0 not equal to 0, right? So this becomes false because 0 is equal to 0, yes. So this 0 not equal to 0, we have written, this condition becomes false. So now the loop will exit. So once the loop exits, the next statement is printf output is equal to percentage d x. So what is the value of x here? So the value of x is minus 6. So here the output is equal to minus 6. Okay. Now what exactly are we calculating here? So the initial number that we gave in was 123, and we got minus 6 as the output. So this is the negative of the sum of the digits of the number. Okay, so the option B is correct here. I hope you are able to understand how this code is working. So yeah, so the initial input. So in questions like this, just take an initial input, take any integer or whatever has been asked of the user, take a suitable input and run the entire while loop, preferably a small number. If I take like a 5-digit number, it will take much more time for me to calculate all these iterations, right? So take a small number, say 2-digit or 3-digit number, and run it through the entire while loop and check what is the answer accordingly. So here I took a number that is 123 and the output came out to be -6. So among the options, I can see that it is basically the negative of the sum of the digits of the number. So option B is the correct one. Okay, I hope that is clear to everyone. So we'll move on to this next question, which is very interesting because it is a exceptional case. Okay, so let us move to the next question. So what will be the printed value of I of the C program in the code given below? So the code is int I is equal to 2, I is equal to I plus plus. So this is something called a postfix operation, and what we are doing here is post increment, because we are trying to increase the value of I by 1. So we are doing a post increment operator using this postfix operator, that is plus plus, and we have written I is equal to I plus plus, and then we are writing printf percentage d I. So what should be the output here? So usually how this post increment operators work is that first it will post increment basically means it will just a minute. Okay, just a moment. Yeah. Okay, so post increment operator basically means it will assign the value first. Okay, this will be step 1, and then step 2 will be the increment operation. Okay, so and when will that increment operation occur? In after this particular statement has been executed. So if we are writing, say, I is equal to some a plus 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 b. Okay, some a is some 1, b is some 0, and yeah, so if this is the case, then what will happen is that in this particular statement I will become 1 plus b, that is 0, so I will be 1, and then after this statement is executed, or after this entire statement has finished execution, a's value will increase by 1 and it will become 2. Okay, after the value of I, or rather this statement is already executed, only after that the value of a will be increased. So here it will assign the value first, the evaluation step occurs first, and it evaluates directly with the current value, and after the evaluation step is over, the increment step occurs, that is the value of a will increase by 1 in this case. Okay, so keeping that in mind, what should be the answer here? Okay, okay. My counter question to those who are writing to is that uh, it assigns that value and then it increments, right? So increment of what is occurring? There should be an increment of I itself, right? Because we are doing the postfix on I, then we are setting this, we are assigning this or evaluating I is equal to I, and then we are doing I plus plus, or we are increasing the value of I by 1. So before reaching this printf statement, the value of I should have increased by 1, right? So why should the answer be 2? You got my point, right? So when we are doing this operation, we are post incrementing I, we are assigning, that is true, that is okay, but that once that particular step gets over, the evaluation step gets over, uh, that statement gets executed. Before the next statement is executed, the value of this post increment occurs, the post increment or post decrement, whatever we have done, that should occur before the next statement is executed. So here the next statement is the printf statement. So before the printf statement, the post increment should have occurred. So why should the value be 2? Okay, so this is a exceptional case. That is what I have told you from beforehand only. So here the answer will be 2, not 3. So this is something which borders on the line of illegality. Like this is a illegal assignment kind of, you can say, but it's not tagged by the C compiler. Like the C compiler will not give you an error here. So when you write I is equal to I plus plus, that basically means that you are assigning the value of I to I, that is the present value, and then you are incrementing. Okay, but what the developers have done, that they are terming it as a kind of illegal assignment operation, especially post fixing on the same value. That is, if you are post fixing or post incrementing or post decrementing on the same variable and assigning it to the same variable, that is kind of a illegal assignment operation. So the value of the post increment or post decrement will not work. Okay, the postfix operation will fail in this case. So this is a exceptional case. You can say it is a pretty well known exception, that postfix operations on the same variable will never work. Yeah, I got that. But if only this much, this particular statement, if you write, if you had written I is equal to I plus 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 something something a plus 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 b minus minus something like this would have been fine. Like this is a legal statement. The exceptions don't really affect this particular statement. If I'm talking about I is equal to I plus 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 a plus 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 b minus minus, so here the exceptions won't work on it. But on this particular assignment, when I write I is equal to I plus plus, just this much, so that is a incorrect use of this postfix operation, right? So in this particular case, the exception has been made by the developers that the post increment operation will not occur. Only the assignment operation will occur. That is, it will assign I to the same value as it has, and there will be no increment or decrement. If I had written I, say I minus minus, there will be no decrement or no increment in the postfix manner. But the prefix one is fine. If I had written I is equal to plus plus I, that would have been perfectly legal. Then you would have got an answer of 3 here. This would have given you a value of 3. Okay, this is a perfectly legal definition. But a postfix operation on this is it will not really work. So that is something that has been made as an exception by the developers themselves. So prefix will work. You can try out, you can play around with these values. It is pretty straightforward to play around with this postfix and prefix operations. Try playing around with this. Maybe you'll stumble upon something. So this is a very, um, you should remember this is a kind of a crucial exception. You should never write it because this, in a sense, it does not also, in a way, it also does not make sense. Why would you write I is equal to I plus plus, right? Like what exactly purpose, what purpose do you want to fulfill here? If you wanted to increase the value of I by 1 or any number, you could have simply written I plus plus, right? And if you wanted to have I to have the same value, you could have simply just left it as such. So this particular statement, it doesn't really serve any purpose as such. Okay, writing I is equal to I plus plus, it does not serve any purpose. So probably that's what the programmers thought, or I'm not sure, but they decided to keep this as an exceptional statement. Okay. Okay, so if it was simply I plus plus, then the value would have been 3. Okay, let me actually write that as well. Sorry. Uh, so I write int I is equal to 2 and I write I plus plus. Then I say print percentage %t I. Okay, so this would have given me a value of 3 because simply writing I plus plus is fine. It will, after this statement is executed, before printf is executed, the value of I will increase by 1. So that is what this particular statement means. So that would have given me a value of 3. Okay, so that is fine. The value should be 3 in that case. Okay, fine. So this is my last question for the day. So it is basically kind of write a code kind of question. So I have already written the code. Just to explain to you, this time from this assignment onwards, I think the codes are being graded. There are four codes that you need to write, and they are being graded. So just bringing you up to par for some sample kind of questions that can come up in the coding section. So this is one where you will have to use the for loop or any kind of looping statement. So the code asks us to print the Fibonacci sequence up to n terms. Okay. So say I can say up to say 50 terms or whatever. Just put any value in uh, place of n and try to. So what is the Fibonacci sequence? So we start with 0 and 1, and the next value is the sum of 0 and 1, which is 1, and the next value is the sum of 1 and 1, which is 2, and the next value is 1 plus 2, that is 3, and so on. So that is basically the Fibonacci sequence. Okay. So okay, here I have taken a value of 10, so let us stick to that. So n is equal to 10 that I have taken, and the initial Fibonacci numbers that we have is 0 and 1. So I have just straight away printed that out. I have used a for loop. I have started from 3. Okay, someone has any queries? Yeah. How else do you want to start? Like, you can start. See, this is just one way to write the code. It's not necessary that you have to follow this. You can directly start this loop from 0, and you can use the first two entries as directly as Fibonacci numbers. Okay, so that is something that you can do. It's not really necessary that you need to initialize this as 0 and 1 and you need to take this. There can be many different ways of solving this. So this I have taken because this seemed pretty straightforward, because I don't need to really calculate the first two numbers, because the first two numbers are pretty much known that it should be 0 and 1. Okay, and I can, the addition part, it will just start from the next number. So I've just initialized the first two numbers because then there the addition part had not taken place. So I just initialized it. But you can also take it separately. It's not in there are n different ways to write a code for a certain problem. So it's up to you. Okay. Yep. Uh, okay, so because I have initialized the first two numbers 0 and 1, I am starting this counter from 3 because 1 and 2. So I have already two numbers which have already been printed out, 0 and 1 here. So I am starting the counter from 3, that is the iterator I am starting it from 3, and I'll move it till 10. So I need 10 Fibonacci numbers, so I'll move it till 10, and I'm incrementing the value of I by 1 at the end of every iteration. Okay, so the first step what I am doing is I am doing y is equal to x plus y because we need a addition which will serve as the new Fibonacci number. So I am doing y is equal to x plus y. So in when I is equal to 3, what happens? Y is equal to x plus y, that is 0 plus 1, that is 1. X is equal to y minus x, that is uh, 1 minus 0, that is 1. And then we are printing out y, that is earlier we had 0 and 1 and we printed out 1. So this is I is equal to 3. Now I is equal to 4. After this I plus plus I operation occurs and the value of I increases by 1, it becomes 4. So now I again do 1 plus 1, that is 2, right? And x is equal to 2 minus 1, that is 1. So now I print 2, okay. Then i's value again increases, and the next operation I do x equal to 1 plus 2, that is 3, and x is equal to 3 minus x, right? So x was 1, so it is 2, and so on until I is equal to 10. So I'll get all the Fibonacci numbers. So how to think of this approach? You can write it in a much simpler manner. I have written in a single statement I am swapping the numbers and so on. So you don't need to, you can simplify it even further. Like when you are writing it for the first time, you can simplify it even further. Let me tell you how. So you have these two initial numbers 0 and 1. So first your step should be to add up these two numbers so that you will get a new Fibonacci number, right? So I'm just say I'm uh, yeah, let me term it as some z. Okay, this new Fibonacci number is some z, which is basically x plus y. Now this x plus y, for the first step, let's say it will be 0 plus 1, that will be 1, that is your new Fibonacci number, right? And now what should be the in the next step, what should be? So you will print, you will simply, I have my new Fibonacci number, so now I'll print this new Fibonacci number, right? So the next step, for the next iteration, what is required? What is required is 1 and 1. We have x at 0, y at 1, but we need, for the next iteration, we need x at 1 and y at 1. So what we will do is, okay, so we'll set y is equal to z. Oh, sorry, not this one. First we will do x is equal to y and y is equal to z. So what I am doing here is that I am just increasing it by one step. So I am setting x to y, that is 1, and y to z, that is 1. So this is z initially, right? X plus y, so this is z. So I am adding, so I am setting the value of x to the previous value of y, that was 1, and the value of y to the previous value of z, that is 1. So in the next, so that in the next iteration you will have x and y as 1 and 1, and when you calculate z, the z will be 2. Now again you will print 2, and after that what you will do, you will move, now x is at 1, y is at 1, you will move x to the value of y, so it will still be 1, but y will move to the value of z, that will, y will be 2. Okay, so you're able to get what exactly is happening here, right? So I'm using two different variables and I'm shifting it one by one across this Fibonacci sequence, so that whenever I add them up to in the next sequence, after printing this new Fibonacci number, I change their values in such a way so that in the next sequence, whenever I add this two values up, or this two variables up, I'll get the new Fibonacci number. So for that I need to shift them one step in the Fibonacci sequence. Okay, so this is a much more simpler way of doing this. If you use another variable z, so you can swap these two numbers pretty easily. I think a swapping code was also there in the previous week's assignments, if I remember correctly. So this is one way to swap that, or you could do the swapping in this manner as well. So it's up to you really how to do it. So you can use a third variable, or you can use uh, two variables and you just directly do that. That's up to you. So this is the code how to print the Fibonacci sequence up to n terms. I hope you're able to understand this. Okay. Okay, if there are no questions, we'll end the session here today. I don't have any more questions for you to solve today. So these are some of the sample questions regarding the looping statements, switch statements, if-else statements. We saw some pretty interesting exceptions also, and we saw a sample code, and we discussed how to write the code. So this will be all for this particular session. I'll see you next week around the same time, 6 to 7 Tuesday.